Good morning, friends. I hope you had a wonderful weekend. Give me a thumbs up if you are doing awesome today, a sideways thumbs if you're doing okay, and a thumbs down if you're not doing so great, and leave a comment below. Let's go ahead and get started with our learning today. Today we are talking about multiplication, but we are going to work with multiplication partial products. Our lesson objective: I will be able to solve multiplication problems using partial products by completing the example problem. Our learning outcome: by the end of this lesson, I will be able to solve multiplication problems using partial products by completing the math connections, leaf, volume, and area homework. Vocabulary: product is the result of multiplying two or more numbers together. So your answer to a multiplication problem is going to be your product. Factor: a number that is multiplied by another number. So the two numbers that you're multiplying are going to be your factors. Multiplication is combining equal amounts. Multiplication is just repeated addition. Partial products. Now this is what we're going to be talking about. Partial products are the parts of the final product that can be combined to find the final product. Here's our example problem. Miss Preer throws a football 25 yards. Mario throws a football 3 times as far. How far did Mario's football go? So with this one, what do you think our two numbers that we're multiplying are going to be? What are those factors going to be? Are 25 and 3. I threw the football 25 yards and Mario throws it 3 times as far. So now we have our 25 and 3. To use partial product, we have to break apart this 25 by place values. We're going to have our tens and then our ones. How many tens do we have? We have 2 tens. 2 tens is our 20. And then how many ones do we have? 5. So that 20 plus 5 is our 25. And we're going to multiply that by 3. And if you want to put a multiplication sign right here, you can. Just remember you're multiplying 20 and 3, then 5 and 3. What is 3 times 2? 3 times 2 is 6, and then we have 1 0. So that makes it 60. That's the same as saying 20 plus 20 plus 20. It's 23 times. That's why multiplication is just repeated addition. Now we have 5 times 3. What is 5 times 3? 15. All right, friends, now we have our 60 and 15. So we just did this part on the whiteboard. We should have our 20 times 3 here, our 5 times 3 here, and we said our 20 times 3 equals 60, and our 5 times 3 equals 15. Now we have to add those two numbers. We have 60 and we have 15. Now we need to add those numbers together. 60 plus 15. Make sure you line those place values up. What is 5 plus 0? 5. Now 6 plus 1. 7. So our answer is 75. Do we leave our answer just 75? No, I always tell you to label your answer. So our answer is 75 yards. And I would even go as far to say Mario threw the football 75 yards. If we wanted to check our answer, how would we do that? The opposite operation. So let me erase my board. Let's do the opposite operation. We multiplied, so what is the opposite operation? Division. How many times can 3 go into 7? We have 3, 6, 9. That's too much. So we have 3 times 2. We always put our number up here. 3 times 2 is 6. We subtract those two numbers. 7 minus 6 is 1. Then we are going to bring down this 5. 3 times what number goes into 15? 5. 5 times 3 is 15. We subtract the 2 and we get 0. So we have no remainders, and the answer we got is 25. Let's look at the original problem. Miss Preer throws a football 25 yards. That means our answer is correct. Make sure you always check your answer. Here is going to be our science connection.
Welcome to the great outdoors. We're so happy you could join us on our walk today.
Just before you arrived, we noticed something very cool.
We saw a great blue heron down by the water looking for fish. I figured that its long, skinny legs were good for wading at the shoreline, and its long neck and beak would make it easier to dart underwater and grab the fish and frogs it was hunting.
The shape of the heron's body helps it to overcome the challenge of getting enough food. But not all birds have that same body shape, even the ones that live in the same environment. Look at the wood ducks over there.
The ducks definitely have shorter legs and necks than the heron did. Does that mean they're adapted to get their food in a different way?
Yep, these ducks will mostly eat plants. Their bills are just right for scooping them out of the water. Take a look at their feet too. Why do you think they're so different from the herons?
The ducks were using their feet to swim, but the heron was just walking. Does the webbing that connects the duck's foot bones help them swim better?
Exactly. Many water birds have webbed feet that catch water to help them swim, like a paddle for a canoe.
Or scuba fins. I've used those before, and they made it so much easier to move through the water.
Did you know that even polar bears have webbed feet that help them hunt in the ocean?
I guess it's like shoes. We have special shoes for different purposes, like those swim fins, or sports shoes for playing soccer, football, or baseball.
Okay, but animals don't exactly wear cleats, you know?
I know, but think about how a sports shoe is shaped. The The hard, pointed parts on the bottom of the shoe dig into the ground and help an athlete run faster and maneuver better by giving them traction. Before the city was built here, bison lived on the prairie and developed hooves like special shoes to help them run faster and escape predators.
So animals with hard, sharp hooves can change direction and accelerate quickly, like a soccer player on the field. Hooves are a very useful adaptation.
Webbed feet for swimming, hooves for running, claws could help with running too then. Or for climbing, like the squirrels I keep seeing.
Those would all help with getting food and with escaping from becoming a predator's prey, or with catching prey in the case of that cheetah. But what about surviving a harsh climate? I don't think hooves or webbed feet would help an organism survive extreme weather conditions.
It can get pretty hot around here, and you'll find that the organisms that survive will have some protection from the heat. Some animals, like the armadillo, are nocturnal during the hot summer. Nocturnal means that they sleep during the day and are awake at night. They hunt at night when it's cooler and don't come out during daylight much until the winter when temperatures have fallen.
And many reptiles, like the Texas diamondback water snake or the alligators you can sometimes see here, beat the heat with thick, scaly skin. It traps moisture in their bodies and keeps it from evaporating too quickly.
What about cold weather?
Many species, like the wood ducks we were looking at earlier, depend on migration to survive a cold winter. During the colder months of the year, they fly south to climates where it's easier to find food. They'll head back north in the spring when weather warms up again.
Some animals that don't migrate may hibernate, like bears, squirrels, and even bullfrogs, like you might see here in the bayou. They spend the colder months of the year in a sleep-like state where their bodies use less energy and become active again when weather is warmer and food more plentiful. Thanks for coming on the walk with me today.
Anytime.
Now it's time for me to head back to the lab.
All right, friends. Now we have our homework. It's our Math Connections leaf volume and area. What we learned today is going to help you with our length and width for rainforest, temperate forest, and the taiga. Let me know if you have any questions. I hope you have a wonderful day, friends. I'll see you next time.